हाँ, काम तो कर ही रहा हूँ। Good evening. Good evening, dear friends. Suraj Singh speaking from Bharat, India. Screen share about concrete document. Yesterday, I produced live for 4.25 hours, but 1.25 hour, 1 hour was not recorded properly. Don't know reason for that. Still, there is some problem. I don't know reason for that. This is some basin for which I will talk about water tightness. Now, now in this range has some information about this. We talked of concrete yesterday, the concrete, and we'll go back to that one. This we go to this file section 5 of concrete, and I was at I think I don't know which page it was. We had talked of us on precast concrete. Precast concrete. We had to talk of precast concrete. This was actually not recorded. Structural precast concrete. This was not recorded due to technical problem. I don't know what. I wrote to them but no answer. So I'm going back to talk of it again. Structural concrete again. Structural precast concrete, and previous was we have completed that with structural precast concrete, and end of part was this was something else. So now we are going to talk of structural precast concrete. General scope, references, submitters, qualifications, quality assurance, quality control, testing, delivery, storage and handling, design, loading actions, and structural member selection, material, general reinforcing bars, bearing pads, embedded steel forming, general tolerances and installation, general survey, guying, bracing and shoring, adjustments and correction, erection tolerances, welding, grouting, and field cutting. Structural precast concrete, and it is work included in this section comprises furnishing all plant labor, equipment, appliances, and material and performing all operations. Connection structural precast concrete works. Let me put my mask in better. This aggregates, this drilling, this is part 2 aggregates, part 3 is a link is between, you know, link is part 2 aggregate, part 3 cementitious materials, part 5 admixtures, part 6 property requirement, part 7 concrete plants, part 8 transportation and placing of concrete, part 9 formwork, part 10 curing, part 11 reinforcement, part 15 hot weather concreting. References are ASH2 standard specification for highway bridges, section 25, ACI 5232 or guide for precast cellular concrete floor, roof and wall units, ACI 533 guide for precast concrete wall panels, ACI 533 on design responsibility for architectural precast concrete projects. ACI 543 design manufacture and installation of concrete piles. AS 5501 has a run guide to emulating cast in place detailing for seismic design of precast concrete structures. ASCI 705 minimum design loads for buildings and other structures. ASCI 31811 building code requirements for structural concrete. BS 8110 structural concrete. BSc and 19914 Euro Code 1 actions on structure general actions, movement actions. BSc and 1992-1-1 Euro Code to design of concrete structure general rules and rules for buildings. ISO 9000 quality management system with fundamentals and vocabulary. Priestess concrete state PCI manual 116. Submittals, manufacturers' literature, contractor shall provide copies of manufacturer's specifications and installation instructions for each item of proprietary metal to be used showing compliance with this specification. Information on equipment, embedded items and other accessories shall also be provided. Design mixes, copies of mixed design, support materials requirements of mixed design shall be in accordance with part 6 and 7 of this section. Product design criteria, loading for designs. Initial handling and erection stresses. All dead and live loads per specification on contract drawings or as required. All other loads specified for member where they are applicable. Product design calculation. Design calculation shall be performed by structural engineer experienced in precast concrete works. They shall cover all the stages of handling, transportation and erection. Design shall be carried out in accordance with requirements of BSEN 1992-1-1 or relevant ACI codes and shall be accepted by engineer. Calculations for design of precast memos shall be supported by statement explaining principles of design and type of analysis adopted. Influence of individual members in achieving overall stability of structure should be considered. Computer program used in this design shall be fully described and detailed. Of inputs and printout shall be presented in a manner which can readily be understood and following requirements shall be met. Program manuals and instructions to program users shall be made available to engineer upon request where such program cannot be demonstrated by a contractor to have been fully checked or where engineer considers necessary. Contractor shall run such test examples as engineer may choose in order to verify completeness and accuracy of program. Members that are expected to weather members that are exposed to weather shall be designed to provide for the movement of components without damage. Failure of joint sales, undue stress on fastness or other detrimental effects and subject to seasonal or cyclic day-night temperature range. Precast systems shall be designed to accommodate construction tolerances, deflection of other building structural members, and clearance of intended openings. Calculate structural properties of framing members in accordance with BS 18110 or BSEN 1992-1-1 or relevant ASA codes. Shop drawings contractors shall provide following information for approval of engineer layout plan and detailed fabrication and placement drawings for each structural precast element. Shop drawings are to include following information: size, grade, profile, and dimensions of all materials used, connection and anchorage details, lifting devices, location, handling limitations, steel reinforcement details, all opening sleeves, inserts, and other provisions in full coordination with trades in contract, identification marks, erection procedure, detailed outline of sequence and methods of erection, including but not limited to type of capsule designed, types, capsule numbers for cranage, method, support, and transportation. Fabrication records. A record shall be kept for every piece of precast element produced showing following type and number, date of pour, concrete test results, shop drawing, reference number, type and duration of curing, date of delivery at site, date of fixing in position. Test reports, copies of all testing and inspection reports, test trial panels. Contract shall provide these trial panels in accordance with the requirements of part 1 of this section. Trial panels shall be retained for reference purposes for acceptance of production work. Qualifications. Structural precast work shall be executed by an approved specialist subcontractor for casting and also for transportation, handling and erection. Contractor may execute this work himself. It can satisfy engineer that it has sufficient experience and expertise in this field as a minimum of contract shall provide satisfactory evidence that tradesmen and their supervisor personnel engaged in such work have a successful experience with work comparable to shown in specified, provide details of organized quality control and testing procedures. Quality requirement precast concrete supply shall have a quality assurance scheme that means ISO 9000 or equivalent. All work shall be performed to secure for project homogeneous concrete having required strength of surface finish, materials, durability and weathering resistance without planes of weakness or other structural defects and free of honeycombs, air pockets, voids, projections, offsets of plane and other defacement of concrete. No alteration or substitution of structural system shown on drawing are permitted unless otherwise specified. Contractor shall supervise and coordinate all phases of structural precast concrete construction process and be responsible for complete manufacturing process. All methods of manufacture and practice of handling raw materials and manufactured concrete shall be reviewed by engineer before execution of structural precast concrete work at least 14 days before beginning of precasting work. Only materials known quality shall be incorporated in the work. All materials shall be properly selected, reviewed and approved by engineer before use and maintained during shipment, storage and use. Construction system and techniques shall be properly selected, reviewed and approved by engineer before use and maintained throughout complete structural precast concrete construction phases. Adequate spare equipment, parts, additional components and repair facilities shall be available for all tools and equipment. Regardless of approvals by engineer, contractor shall be responsible for all methods and methods of structural precast concrete work. If work doesn't meet specified requirement, contractor shall at no additional cost to employer implement a removal, replacement of remedial works, revise procedures or materials to prevent reoccurrence of unacceptable work. Quality control. Contractor shall prepare and provide quality control program for structural precast concrete work with particular attention to details, pre-checking procedures and close supervision and particular contractor shall in order to ensure that proper work is performed to prevent later corrective actions assign at least one experienced supervisor full-time to provide quality control for structural precast concrete work. Assignment will not relieve contractors other quality control personnel of their duties related to quality control of structural requirements and surface finish of structural precast concrete work. Contractor shall arrange for training of its quality control personnel who perform quality control of structural precast concrete work and whose training shall include but not be limited to material evaluation, spatial mix, design technique, mix placement, vibrator selection and use, formwork detail, formwork protection, release agent use, reinforcing steel, detailing and installation, finishing, equipment and technique, corrective procedure and protection of completed work. Contractor's quality control person shall be responsible for verifying all details necessary to produce final structural design objectives. Contractor's quality control person shall also verify quality of structural precast concrete work and guide production of results which be within acceptable physical tolerances. Testing. Concrete shall be tested as specified in Part 6 of this section. Contractor shall furnish labor required to facilitate testing. Inform engineer with at least 1 day's advance notice when concrete is to be placed. Provide facilities for concrete tube test. Test tubes, provide material samples and access to materials as required for testing. Should matching plant be located more than 500 meters away from site office? Contractor shall provide suitable transport accessible to engineer for sole use of engineer's staff. Contractor shall station a qualified technician at casting site to continuously test, inspect and report on following. That concrete testing is being carried out in accordance with the requirement of Part 6 of this section. Check following and verify conformance with the specified requirement and approved shop drawing. All reinforcing bars, embedded items, formwork. Check all openings and provisions for coordination with all trades in contract as shown on approved drawings. Contractor shall provide facilities and equipment for conducting all tests specified herein, except for strength tests which shall be carried out by an approved independent testing agency. Delivery, storage and handling. Structural precast elements shall be removed from form without damaging or overstressing and stored and placed in transportation On a stable bed that shall not allow distortion of member. Separate stacked member with suitable battens and bracing. Make each member with an identifying reference or piece mark and date of casting. All piece marks are to be correlated with test report and plan layout or erection drawing. Structural precast elements shall be transported with sufficient battens, bracing and supports so as to prevent overstress by vibration or impact loading. Contractor shall submit proposed method for transportation to engineer for approval. Structural precast units shall be stored, handled and transported in a manner that shall avoid undue strains, air cracks or straining or other damages. Contractor shall deliver units from casting site to project site in accordance with the schedule and proper setting sequence. Structural precast units shall be stored free of ground and protected from wind or rain splashes. Units shall be covered and protected from dust, dirt or other staining materials. During fabrication, construction, after erection, contractor shall protect castings to avoid possibility of damage. Design, loading actions and structural members selection. Provisions of this clause shall apply if contractor is responsible for design of structural precast units. Precast elements shall be designed to withstand all loading conditions against which strength and serviceability must be measured. Vertical load shall include self-weight of precast elements, floor coverings and live loads as indicated on contract drawings. Wind load shall be calculated based on wind speed provisions in section 1 part 1 clause 152. Account shall be taken of loads and deformation caused by temperature and time dependent deformations. For such purpose 55 degrees Celsius temperature variation and 90% relative humidity should be considered for all members except exterior elements, and facade elements shall consider 85 degrees Celsius. Precast elements shall be designed in accordance with BSEN 1992-1- or relevant ACI code. Design tensile stress should not exceed design flexural tensile stress of concrete at particular age of concrete. Nominal cover to steel including links must meet the durability requirement of severe conditions of exposure and to meet requirements of 2-hour period for fire resistance as provided for BSEN 1992-1- or relevant ACI code. Total deflection of precast elements should be limited to 1/350 of span of this element. Plan and design of openings for building services where required necessary materials. Contractor shall obtain cement, aggregate and water from single source sufficient to complete entire structural precast concrete work to assure regularity of appearance and uniformity of color. Again I say, contractor shall obtain cement, aggregate and water from a single source sufficient to complete entire structural precast concrete work to ensure regularity of appearance and uniformity of color. Contractor shall provide all material in accordance with and meet all applicable requirements of this section. Reinforcing bars shall conform to requirements of part 11 of this section. Bearing pads, these shall be elastomeric bearing pads, elastomeric neoprene conforming to AS2 standard specifications for highway bridges, section 25 with following stipulation. Use unfactored load for design. Maximum compressive stress 0.7 MPa, maximum shear stress 0.07 MPa, maximum shear deformation 1/2 thickness, half thickness, maximum compressive strain 15%. Embedded steel. All embedded items shall be of stainless steel grade 316L. Forming. General forms and casting beds are to be firmly seated so as not to deflect or be displaced under concreting or tensioning load. Correct for thermally induced strains or forces. For member penetrations larger than 150 mm, coring or field cutting is not permitted unless approved by engineer. Clean and coat forms with release agent before installation or reinforcing or embedments. Tolerance, a permissible deviation of formed Surfaces are not to exceed tolerances outlined in PCI Manual 116, where items are summarized or modified in Table 17.1. Tolerances for structural precast concrete. Dimensions now: length is plus minus 5 mm, width is plus minus 3 mm, thickness is plus stem is plus minus 3 mm, flanges plus minus 2 mm, embedment or penetration location plus minus 0.2%, straightness plus minus 3 mm for 300 centimeter or 3 meter, and squareness plus minus 3 mm. Installation general. Installation general. Contractor's erection responsibilities include safe and proper placing, aligning, and labeling of structural precast elements on accepted bearing surfaces and effecting their proper fastening. Survey before placement of structural precast elements. Contractor shall do survey and maintain all temporary supports shown or required to control alignments and deflection. Temporary support shall be retained until framing elements braced, thereby have attained integral stability in accordance with design. Guying, bracing, and shoring. Contractor shall install in proper sequence and maintain all temporary supports shown or required to control alignment, deflection, and stress level. Temporary support shall be retained until framing elements braced, thereby have attained integral stability in accordance with design. Adjustments and correction. Contractor shall compensate and correct for misaligning effect of temperature, draw from welding, bolting, or erection sequence of grouting. Erection tolerance. Following erection tolerance do apply unless otherwise specified. Variation from plumb 6 mm in 6 meter run means 1 mm in 1 meter run, and 12 mm total in 12 meter or longer run. It may be 18 meter, then even it's 12 mm. Variation from level or elevation 6 mm in runs. 12 mm in 12 meter run and maximum 12 mm at single location. Variation from position in plant plus minus 12 mm maximum. Offsets and alignments of adjacent members or joints 1.5 mm and 3 meter run 6 mm maximum. Welding. Where permission for welding is given by engineer, following shall apply. Welding shall not affect until all adjacent elements to be connected have been aligned firmly, seated, and braced. Control of heat buildup by limiting voltage, electrode size, and rate. Spalled or heat damaged concrete around welding shall not be acceptable. Spalled or heat damaged concrete around welding shall not be acceptable. Grouting. Joints, gaps, and connections shall be filled with grout as shown on drawings and approved by engineer. Field cutting. Field cutting of holes may be done only with engineer's concurrence and only with power saws or core drills. Steel reinforcement of pre-stressing stand shall be avoided. Where reinforcement of stand is damaged, unit shall be repaired to satisfaction of engineer or rejected. Maximum holes size shall be 150 mm diameter or as limited by member size or stand location. Cracks, spells, and sharp corners created by field cutting are to be ground, eased, and patched with epoxy type bonding and patching compounds. Cracks, spalls, and sharp corners created by field cutting are to be ground, eased, and patched with epoxy type bonding and patching compounds. Now, pre-stressed concrete. Pre-stressed concrete. We have to do pre-stressed concrete. So, slat, slat. Oh, it's not that, sorry. Something wrong happened. Slat, yeah. going to show you something like this. Pre-stress concrete.
बारिश कैसा मौसम हो रहा है?
वैसे ये सीजन general scope reference of metal storage and handling pre-stressing general wires and strands sheets cores and ducts anchorages jacking equipment tensioning grouting grout mixer grout trials pre-stress concrete pre-stress concrete general. This section describes requirements of pre-stress and pre-tension concrete, including this section describes requirements of pre-stress, post-tension concrete, including materials and procedures for installation, stressing, and grouting. Related sections and parts are as follows: Part 2 aggregate, Part 3 cementitious metal, Part 4 water, Part 5 admixtures, Part 5, Part 6 property requirement, Part 7 concrete plants, Part 8 transportation and placing of concrete, Part 9 formwork, Part 10 curing, Part 11 reinforcement, Part 15 hot weather conditions, Part 16 miscellaneous. ACI 325 seminar recommendations of designing pre-stress concrete pavements, ACI 343R analysis and design of reinforced concrete bridge structures, ACI 3503 are seismic designs of liquid containing concrete structures, ACI 358 are analysis and design of reinforced and pre-stress concrete guideway structures, ACI 372 designs and construction of circular wire and strand wrap pre-stress concrete structures, ACI 373 are design and construction of circular pre-stress concrete structures with circumferential tendons, ACI 4233 are recommendations of concrete members pre-stress with unbonded tendons, ASTM 881 or 881M standard specifications for steel wire, deformed, stress relieved or low relaxation for pre-stress concrete railroad ties. ASTM 882-882M standard specification for filled epoxy coated 7 wire pre-stressing steel strand. ASTM A641 A641M standard specification for zinc coated galvanized carbon steel wire. ASTM A416 A416M 10 standard specification for steel strand uncoated 7 wire for pre-stress concrete. AWW D110 wire and stand wood circular pre-stress concrete water tanks, BS188 on testing concrete, and BS EN12350 testing fresh concrete, BS EN12390 testing hardened concrete, BS5896 specification for high tensile steel wire and strand for pre-stressing of concrete, BS EN1992 Euro 2 design of concrete structures, GSO ISO 1920 testing of concrete submetals. Samples. A 1 meter length sample of strand. A 1 meter length sample of strand shall be taken from every 1000 meter of strand. 1 meter length sample of strand shall be taken from every 1 kilometer of strand to be installed in works with a minimum of 1 sample of strand per reel on site in presence of engineer for strand test at an independent laboratory approved by engineer. A reel shall only be accepted if both breaking load and 0.1% proof load of sample exceeds characteristic load given in BS 5896 table 6. A minimum of 3 samples of strand shall be taken at random from each reel of pre-stressing steel on site in presence of engineer. Reel on site shall only be accepted if relaxation values determined by tests are equal to or lower than specified relaxation class of BS 5896. Sample requirements and frequency of a pre-stressing wire shall meet requirements of AWWA D110 and ACI 372R. Technical details of proposed materials and equipment shall be submitted. Technical details of proposed materials and equipment shall be submitted. Details of jack type and size is submitted to allow for clearances to be checked. A calibrated stress recording device shall be used. Design data. Contractor shall submit details of proposed grout mix, design, tendon extension calculation, vent pipe spacing and location details, detailed execution and shop drawings, calculation notes, other submittals, curriculum vitae and experience record of supervisor proposed who shall have a minimum of 5 years experience in such a position. Safety procedures including warning signs, barricades and communication between different stressing locations. Name of proposed pre-stressing company giving details of previous projects. Storage and handling. Pre-stressing steel shall be stored in pallets at least 300 mm above ground and be protected from contamination by wind blown sand or rain. Pre-stressing stand shall be in coils of sufficiently large diameter to ensure that strand pays off straight. Pre-stressing general. Pre-stressing operations shall be carried out only under direction of an experienced and competent supervisor, and all personnel operating stressing equipment shall have been properly trained in its use. In addition to normal precautions against accident, which should be taken at all times for the whole of works, special care shall be taken when working with or near tendons which have been tensioned or are in process of being tensioned. System of pre-stressing used shall be a system approved by engineer. Such system shall be used strictly in accordance with recommendations of system manufacturer. Under no circumstances shall equipment or fittings designed for use with one system of pre-stressing be used in conjunction with equipment and fittings designed for use with other system. Pre-stressing components shall be stored in clean dry condition. They shall be clean and free from loose rust and loose mill scale at time of fixing in position and subsequent concreting. Slight rusting of steel which can be removed by moderate rubbing is acceptable, but surface shall not show signs of pitting. Wires and strands. All pre-stressing strands shall be 7 wire. All pre-stressing strands shall be 7 wires of super stabilized low relaxation strands with a guaranteed ultimate tensile strength GAUTS of not less than 1770 MPa, complying with BS 5896 or relevant STM standards. All pre-stressing wires shall be cold drawn, high carbon wire meeting requirements of ASTM A821/A821M. Type B having a minimum ultimate tensile strength of 1448 MPa to 10000 psi prior to galvanizing. Zinc coating for galvanizing shall meet requirements of ASTM A641/A641M with a minimum weight per unit area of uncoated wire, minimum weight per unit area of uncoated wire surface of 259 gram per meter square, 0.85 oz per feet square. Minimum ultimate strength of wire after galvanizing shall be no less than 1241 MPa, 180,000 psi. All wires or strands to be stressed at same time shall be taken from same parcel. Coil numbers of steel used for each tendon shall be recorded. Welding of tendon shall not be permitted. All cutting of strands shall be carried out using a high-speed abrasive cutting wheel or friction saw at not less than 1 diameter from anchor. Cutting shall effect only after contractor has submitted stressing records and engineer has approved them. In writing, flame cutting will not be permitted. Tendon shall be built into works strictly in accordance with system which is being employed. Sufficient strand shall project from anchorage to allow jacking effect at the stressing end of tendon. Cable, that is tendons or individual strands comprising cable, shall not be kinked or bent. No strand that has become unraveled shall be used. Pre-stress concrete. Sheaths, cores and ducts. Sheaths, cores and ducts. Just hold on. What is that? Sheaths, cores and ducts. Sheaths shall be accurately located both vertically and horizontally as described in a specific project specification. Unless otherwise described in a specific project specification, tolerance in location of center line of sheath shall be within plus minus 5 mm. All sheaths and cores shall be maintained in their correct positions during placing of concrete. Unless otherwise agreed with engineer, sheaths shall be rigidly supported at points not less than 50 mm or not more than 500 mm apart. Method of support shall be to approval of engineer. Where sheaths are used, number of joints shall be kept to a minimum and sleeves connectors shall be used for jointing. Each joint shall be adequately sealed against ingress of materials. Joints in adjacent sheaths shall be staggered by at least 300 mm. Sheaths shall be kept free of matter detrimental to bond between grout and and sheath, and except for material sealing a sheath joint between sheath and concrete. Within 24 hours of concrete being placed, contract shall satisfy engineer that tendons are free to move if they are in ducts, or that ducts are free from obstruction. Number and position of grouts, number and positions of grout, vents for entry and outlet points, and for checking that entire length of duct has been adequately grouted shall be agreed with the engineer before ducts are formed. Vents shall be provided at low points in tendon profile to allow disposal of water that may have collected as a result of rain or curing. For example, vents shall be sealed before grouting operations beginning. Anchorages. Anchorages and blocks and plates shall be positioned and maintained in position during concreting so that center line of duct passes axially through anchorage assembly. All bearing surfaces shall be clean before concreting and tensioning. Anchoring of pre-stressing wires shall meet requirements of AWWA D110 and ACI 372R. Jacking equipment. All jacking equipment used for stressing operations shall be of type applicable to system adopted. Jack and pumps shall be calibrated at an independent facility in presence of engineer before beginning stressing operation. Calibration of equipment shall take effect at 6-month intervals for equipment permanently present on site. Whenever new equipment is brought to site or equipment is removed and returned or serviced, recalibration of equipment as described be required. All gauges, load cells, dynamometers, and other devices used for measurements shall have a reading accuracy of within plus minus 2%. Stressing equipment of pre-stressing wires shall meet requirements of AWWA D110 and ACI 372R. Tensioning. Tensioning. Contractor shall submit details of proposed stressing solution loads and stressing sequence to engineer for approval. Tensioning shall be carried out only in presence of engineer or its representative unless permission has been granted to contrary. Contractor shall ensure that personnel carrying out stressing are provided with particulars of required tendon loads, order of stressing and extensions. Immediately before tensioning, contractor shall prove that all tendons are free to move between jacking points. Unless otherwise permitted in contract, concrete shall not be stressed until it has reached at least age at which 2 test tubes taken from it attain specified transfer strength. Tubes shall be made and tested as described in BS 1881, BS EN 12350, BSEN 12390 or GSO ISO 1920. They shall be cured in similar condition to be concrete to concrete to which they relate to and in a manner approved by engineer. Friction factors assumed for calculation of tendon extension shall be verified by on-site measurement of force extension relationship of a typical sample of installed tendons. Contractor shall establish datum point for measuring extension and jack pressure to satisfaction of engineer. Tendon shall be stressed at a gradual and steady rate. Tendon shall be stressed at a gradual and steady rate until they attain force required. Maximum force exerted on 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 shall not exceed 75% of GUTS guaranteed ultimate tensile stress of strand for purposes of cable detensioning where installed stands to be discarded. Jacking force may be increased to 80% GUTS. Force in tendons shall be obtained from readings on a load cell or pressure gauge and extension of tendons measured. Two readings shall conform to limits set by engineer, but in all cases, force in tendon as computed from extension measurement shall be within 5 plus minus 5%. Now plus 5% to minus 2%, not plus minus 5, plus 5% to minus 2% of force indicated by gauging system. So I can say it again. Force in tendons shall be obtained from readings on load cell or pressure gauge and extension of tendons measured. Two readings conform to limits set by engineer, but in all cases, forces in tendon as computed from extension measurement shall be within plus 5% to minus 2% of force indicated by gauging system. When stressing from one end only, pull in at dead end shall be accurately measured and appropriate allowance made in measured extension at live end. If calculated and measured extension vary from each other by more than plus minus 6%, then corrective action shall be taken. This may involve detensioning and retensioning of tendons if required by engineer. When required force, including overloads of short duration, has been applied to satisfaction of engineer, tendon shall be anchored. Jack pressure shall then be relieved in such a way as to avoid shock to anchorage or tendon. If pulling of tendons at completion of anchoring is greater than that acceptable to engineer, tendon shall be detensioned and tendon tensioned again. Engineer may direct that force in whatever tendon be tested by rejacking. This shall only be instructed if there is doubt that calibration of tensioning equipment is accurate care shall be exercised by contractor during retention to ensure that jacking load does not exceed more than 80% of GUTS guaranteed ultimate tensile stress of strength. It is necessary to crop tendons to enable ducts to be grouted. This shall be delayed as long as is practicable to the time of grouting. In all other cases, unless otherwise agreed with the engineer, tendon shall not be cropped less than 3 days after grouting. Contractor shall keep full records of all tensioning operations, including measured extensions, pressure gauge or load cell readings, and amount of pull in at each anchorage. Copies of these records on suitable forms shall be supplied to engineer within 24 hours of each tensioning operation. Tensioning pre-stressing wires shall meet requirements of AWWA D110 and ACI 372 of grouting. Grouting grouting shall affect only with written approval by engineer. Engineer shall give in writing that it can be commenced with. All ducts shall be thoroughly cleaned by means of compressed air and all anchorages shall be sealed before grouting. Ducts shall be grouted as soon as practicable after tendons in them have been stressed and engineer's written permission to commence grouting has been obtained. Grout shall be injected in one continuous operation and allowed to flow from vents until consistency is equivalent to that being injected. Maximum time between mixing and injection shall not exceed 30 minutes. Duct shall be completely filled with grout. Vents shall be sealed consecutively in direction of flow and injection tube sealed under pressure until grout has set. Filled ducts be protected to satisfaction of engineer to ensure that they are not subject to shock or vibration for 1 day. 2 days after grouting, level of grout to injection and vent tubes shall be inspected and made good if necessary. Contractor shall keep full records of grouting, including date each duct was grouted, proportions of grout and admixtures used, pressure, details of interruptions and topping up required. Copies of these records shall be supplied to engineer within 3 days of grouting. Pre-stressing wires shall be protected against corrosion and other damage by shotcrete cover coat meeting requirements of AWWA D110 and ACI 372 are grout mixer. Grout mixer. Grout mixer shall produce a grout of colloidal consistency grout mixer shall produce a grout of colloidal consistency. Grout injector shall be capable of continuous operation with a sensibly constant pressure up to 0.7 MPa and include a system of circulating or agitating grout whilst actual grouting is not in progress. All baffles to pump shall be fitted with seal strainers size BS14. Equipment shall be capable of maintaining pressure on completely grouted ducts and be fitted with nozzle which can be locked off without loss of pressure in duct. Pressure gauges be calibrated before they are first used in works and thereafter as required by engineer. All equipment be thoroughly washed and clean water at least once every 3 hours during grouting operations and at end of use for each day. Contractor shall ensure that standby grouting equipment is available in event of a breakdown. Grout trials. Contractor shall carry out grouting trials to satisfaction of engineer before actual grouting effects. Unless otherwise directed and agreed as a result of grouting trials, grout shall consist only of ordinary Portland cement, water, and an approved expansion agent. Have a water cement ratio as low as possible, consistent with necessary workability. Under no circumstances shall water cement ratio exceed 0.4. Not be subject to bleeding in excess of 2% after 3 hours or 4% maximum when measured at 18 degrees Celsius in a covered glass cylinder approximately 100 mm diameter with a height of approximately 100 mm, and water shall be reabsorbed after 24 hours. Admixtures containing chloride or nitrate shall not be used. Other admixtures shall be used only with written permission of engineer and used strictly in accordance with manufacturer's instruction. Grout shall be mixed for a minimum of 2 minutes and until a uniform consistency is obtained. So there were 3 points in grout. Consist only of ordinary Portland cement, water, an approved expansion agent. Have a water cement ratio in no case more than 0.4. Not be subject to bleeding in excess of 2% after 3 hours or 4% maximum when measured at 18 degrees Celsius in a covered glass cylinder approximately 100 mm diameter with a height of approximately 100 mm, and water shall be reabsorbed after 24 hours. Now, testing of water retaining structure. Very important point. Water retaining structure. This is something we can say an important point here. Water retaining structures, and we may say BS 8007, that is real code for water tightness. Uh, I think this, I think it is. Just trying to locate if I can. I don't think so I can find from this. Well, I think I cannot find from this, so continue like this. And you can say that uh, now we are on testing of water retaining structures. Testing of water retaining structures in this general scope, references, submittals, general, testing, general, cleaning, testing require a procedure, walls, roofs, disposal of water used for testing. Testing of water retaining structures. Now, this part of specification applies to testing of structures that are designed with intention of retaining water. Water retaining structures. Related sections that apply are General, Part 1, Part 39 Inspection and Testing of Hardened Concrete, Part 14 Protective Treatments for Concrete. References BS 8007 Code of Practice for Design of Concrete Structures for Retaining of Aqueous Liquids. And submittals, contractor shall record and submit to engineer within 24 hours results of water tightness test carried out. General. Water retaining structures shall be watertight when subject to external groundwater pressure or to test as specified in this part. That is testing. Contractor shall test water tightness of water retaining structures, including storage, reservoirs, and other miscellaneous structures that require to be watertight. All water used for testing shall be potable or irrigation water, and contractor shall make arrangements for supply and disposal of this water. Water retaining structures be tested for water tightness after completion in accordance with following methods or as directed by engineer. The structure shall be filled with potable or irrigation water in stages not exceeding 1 meter in 24 hours. 1 meter in 24 hours. Held at each water level for such time as engineer may require. Should dampness or leakage occur, water shall be drawn off and defects remedied to satisfaction of engineer. In case of structures Uh, in case of structures which are subdivided into individual tanks, each individual tank shall be tested separately. In case of underground or partially underground structures, testing shall take or in effect before application of waterproofing membrane, liner material or perimeter drain, filter material or backfilling is placed against walls. In case of hopper bottom tank, this shall be taken this shall be taken to mean that no material is placed against vertical external walls of tank. Sloping walls of hopper bottoms of tank being assumed built directly against excavation apart from blinding concrete. No placing of material against walls shall no placing of material against walls shall affect until engineer has given written approval and acceptable of water retaining structures as watertight. Filling shall not affect earlier than 28 days after casting of final sections of structure which be stressed by filling of structure. Testing shall not be undertaken until the structure to be tested has been completed structurally, including roof, if if whatever, and has been passed by engineer in writing as satisfactory in all respects other than water tightness, especially in regard to final finish of work. Notwithstanding satisfactory completion of 7 days test, leakage, cracks and damp patches and sweating visible on outside faces of structure shall be rectified from water phase by whatever injection system to approval of engineer. Repair making outer face only watertight will not be accepted. This applies to bobbin holes also. Structure shall be retested until water tightness is approved by engineer. Should structure fail a test in above respects, contractor shall immediately take steps as may be necessary to ascertain nature and positions of defects or leakages, empty structure, remedy defects in a manner approved by engineer, employing workers who are specialists in this class of work. When remedial work has been completed in manner approved by engineer, testing and if necessary rectification be repeated until satisfactory test is achieved. If necessary, extreme cases of lack of water tightness, engineer may reject structures or portions thereof. Cleaning. All water retaining structures shall on completion be carefully cleaned of all debris to complete satisfaction of engineer as follows. Shall be brushed down on all internal faces with a stiff broom while still dry. All resulting debris removed. All associated reservoir pipe work shall be cleaned in accordance with specified requirement. A structure shall then be flooded with approximately 75 mm of clean water. Whole internal faces shall be carefully brushed down with stiff brooms using water continuously until all faces are clean. Water shall then be drained off walls and floors, hosed and flushed with clean water until perfectly clean. Testing procedure. Walls. Testing procedures. Walls. After completion and cleaning of structure and all associated pipework, and if whatever, contractor shall fill structure up to top water level and leave for a stabilizing period of 21 days in order to allow for absorption and autogenous healing to take effect. Again, now we are talking of procedure, how to fill in, how to test. This procedure we are talking, testing procedure it is, so be careful about this. Very important. This is real, you know, real test of whatever is retaining structures, water retaining structures. After completion, after completion and cleaning of structure and all associated pipework, whatever, contractor shall fill the structure up to top water level and leave for a stabilization period of 21 days in order to allow for absorption and autogenous healing to effect. Water shall be added over this period to maintain top water level. Contractor shall ensure that all pipes and spatials are available in ample time ahead of testing. Two sets of evaporation trays. Two sets of evaporation trays shall be provided along with two sets of rain gauges. Levels in trays and structure shall be made and recorded by a hook gauge with vernier attachment. Before and during testing, flows in structure under drainage, flows in structure under drainage, if whatever, shall be monitored, measured and recorded. Each under drain shall be numbered and observation reported by under drain number to facilitate analysis of data. All leaks shall be repaired within 1 month of their detection. On 22nd day, two shallow watertight evaporation trays of area 0.4 square meter shall be filled with 75 ml of water and placed to float in structure. Water level in structure shall be recorded and test commenced and carried out over next 7 days. Readings of water level in structure and trays shall be made and recorded every 24 hours over this period. If water level in tank falls by more than indicated by evaporation trace or other sign of leakage occurs by end of test period, contractor shall search and mark all areas of defect. The structure shall then be emptied and defects made good as specified herein. After completion of remedial measures, structure shall be refilled and tests repeated. This process shall be repeated until the structure is watertight to satisfaction of engineer. Fall of water level in structure over test period of 7 days minus fall accounted for by evaporation and rainfall shall not exceed 1 over 500 of average water depth of full structure or 10 mm whichever is less. I'll give you one example of this test. Let us finish this first. Roof. Roof of structure shall be tested for water tightness before laying of roof membrane. Roof and fittings shall be hosed down vigorously, and this shall be repeated in such a way as to keep roof wet for 3 successive days. Roof and fittings shall be deemed satisfactory for water tightness if no discernible leaks or damp patches show in soffit. Roof covering shall be completed as soon as possible after testing. Disposal of water used for testing. Contractor shall provide suitable means for disposal of water used for testing such that no damage results to facilities, structures or property. These means shall be subject to approval of engineer and local authorities. Details shall be submitted to engineer on request. Contractor shall be responsible for damage caused by its filling, testing, flushing and wastewater disposal operations. Now before this, let us go to what I'm talking of. I'm talking of something where I'm giving an example. Let us say that this is a tank, you may see, or I may, I can say that rotate it. Let us rotate it and see how it works. It's like this. This is, a seawater basin here. This is about 100 meter length and about 80-meter width. You can see that here. Let's blow it a little. You can see this 100 meter this way and 80-meter this way. It is seawater basin for cooling water distribution to industries within facility. Now, has expansion joint every 7.5 meters and this wall is 400 mm thick. This is given here, and this portion is slope between this level and this level. There are different levels. This is higher level and this is lower level. If you can see here in section, this is section here. This is you can say thickness of slab is 500 mm here. This is 500 mm slab, bottom slab, raft slab, whatever you can call it. And this is, you can say, this wall is 500 mm, this wall I think 400 mm. So this is 40 meter here. This is 6 meter depth here, 6 meter depth here, and here it is 10 meter depth here. So a difference of 4 meters in 2 levels, and this is sloping one. Here is a pump house outlet. This is pump house about 10 meters width. There is outlet here. So this is top of wall, and this is inlet of water from here. Sea water is coming here, inlet here, and this is outlet. So it is seawater basin for cooling water distribution to industries within expansion joint base slab RC structure sketch 13 it is. So it is seawater basin plan for cooling water distribution to industries. Now what it says, let us see, that's important. I have told you about 80 meter is this and 100 meter is this. 40 is valve. Now safety requirements, excavation to 6 oblique 8 meter deep, all excavation safety required, dewatering may be required, blinding safety required, concrete production safety required, foundation safety procedures, RCC wall safety procedures, wall working platforms, pump rooms wall safety, pump rooms roof safety, all internal and external scaffolding, concrete protection to RCC surfaces, safety required, safe safety during water tightness testing. This was just something. So we are going to test this water structure, structural tank. This is water retaining structural seawater basin. It is called seawater basin. So basin it is, and you can yourself understand what big quantity of water is there because its size is 100 meters and 80 meters itself, whereas this portion itself is 40 meter and this portion is 50 meters minimum. So I think something like that, and 10 meters something. So this is 50, this is 40, and this is 10. So this 100 meters, and quantity of water required you can understand yourself. You will show you calculations actually now. What we are going to do in this case, you have seen now plan and section, so we can move further on this. I'll give you now a statement on this. Seawater basin water tightness BS 8007 1987. This is water tightness according to BS 8007. This is code. This is a very reliable code, and generally it is used for testing hydraulic structures or water retaining structures. Now, what is given here is the scope of this. We can say our statement contains scope, definitions, responsibilities, safety, methods, procedures, equipment, attachment, etc. etc. General procedure or method statement, and we cannot dispute on that. And if you want to alter that, your pleasure, I don't mind that. But content of test must be there, that's most important. Technicalities must be contained in. Now to transport seawater to seawater basin and testing measure volume based purpose for this method statement to be defined. To define complete procedures to be adopted for conveying seawater by pumping from shore to location of seawater basin on plant site. It's only for purpose of testing because seawater would come through permanent pipes, ductile iron pipes. Two ductile iron pipes are placed in, so that's different matter. We are just talking of testing. We are not talking of communication or conveyance of water, how it shall happen. We are just talking of something for purpose of testing because this seawater, let's say we are not going to use potable water in this case. Already it is going to work as seawater. So now to transport this water, okay, that's one point. It's up to us whether we take seawater or we take water directly by tanks. It's a different matter. Now, I am just giving a method means how to test seawater, how to test water tank, water retaining structure. Purpose of this method statement is to define complete procedure to be adopted for conveying seawater by pumping from shore to location. Since quantity of water required to conduct water tightness test pertinent seawater basin conditions is very high, it is not convenient to be transported and filled into basin using water tankers efficiently and accommodate. Depends still. Now, definition something else, responsibility something else. Leave that aside because we are not concerned with responsibility. We are just saying now. Refer to this one sketch I was showing here. This was general safety. Means it's because we have to check about traffic, means how to divert traffic. No. Traffic directory signs for ramp, breakers on third road crossing shall be installed, and on exposed pipe route safety tags shall be installed with cones. It protection arrangement shall be made for plants at intakes. A full-time dedicated attendant shall be kept. All these are safety measures. This is something else we can detail in that. Procedure involved this method sketch. In number 13 I use it, doesn't matter. Indicative only this is, so let us say further. Now we are talking of something other than this. Now laying 100 mm dia holes from sea to sea water approximately 1800 meters, or you can say 1.8 kilometers. Refer to sketch point 128, not included in this. Intake at sea and discharge to basin respectively. Construction of concrete anchor at sea to fix intake pipe sprout horizontally and vertically, as well as to fix 2 number heavy duty centrifugal pumps at point number 1, which is not shown here. We took that at sea where we wanted to bring water in, we put all that. There are 3 number road crossings, okay, on way, which were 2.256 were shown on that sketch. This also we provide pipe sleeves, they are in road to be inserted this pipe in form of ramp, spade, breakers, etc. etc. Otherwise, sleeves shall be inserted by road cutting, filling and making good removed when jobs over. Now, my preference is to cross road by inserting sleeve below ramp, as road are not very busy. Now, install either a round clock 24 hours working generator to supply electricity to pumps with distribution board at point indicated 1, not shown in, or to have electric connection through. Installation of generator to forge at force point. Foregoing location may not pose any objection from environment angle or from fire safety sense. Locations far away from plant area. Install a number of clamping platform. Now question is water heads calculation indicative only. Now head loss, we are going to see what head is lost at intake section 1 meter. We can say at intake disposal 1 meter, vertical head loss 25 meters, at point 8 loss is 10 meters, total vertical head loss is 37 meters. Length of pipe for friction loss 1800 meter, 4 FLV square or 2 GD pipe friction, 5 friction coefficient 0.015 is equal to 4 into 0.015 into 1800 into 1.5 into 1.5 oblique 29.81x into 0.1 is equal to 123.9 meters. Total head loss equal to static loss plus dynamic loss equal to 37 plus 123.9 is equal to 160.9 meters. Work done is equal to 42,000 into 160.9 kgm equal BHP is equal to 14,000 into 160.9 divided by 27, 270,000 is equal to 25 units. IHP equal to 35 units. Now water flow velocity has been assumed to be 1.5 meter per second, giving a discharge of 42 cubic per hour. Now it shall take 20 days to reach transport 20,000 cubic meter water to basin, keeping maintaining round clock pumping. Now seawater basin plant pumping. What is this plant pumping? One column is day, other column is quantity pumped in, and third is quantity cumulative. Now what is that? Number 1, day number 1, we are taking 1008 cubic meter, day number 1 according to our requirement, which is 1008 day number 1. Day number 2 is 1008 again, so cumulative is 2016. Day number 3 is 1008, so it is 3024. Day number 4 is again 1008, so it is 4032 cubic. cubic meter. Fifth is 1008 again and 5040. Sixth is 1008 again and 6048. Then seventh is 1008, 7056. Eighth is 1008, so 8064. Nine is 1008, so 9072. Tenth is 1008, so 10,080 cubic meter. 11th day 1008, no, 11088 cubic meter. 12 is 1008, 12096 cubic meter. 13 is 1008, this is 13104 cubic meter. 14 is 1008, so 14112 cubic meter. 15 is 1008, 1510220 cubic meter, and 16 is 1008, 16128 cubic meter. 17 is 1008, 17136 cubic meter. 18 is 1008, 18144 cubic meter. 19 is 1008, 19152 cubic meter. 20 is 1008, 20160 cubic meter. And 21 is 1008, 21168 cubic meter. First phase testing. Tank completed with protective coatings as specified and sealant applied shall be cleaned and filled to normal maximum level to meet requirement of class 92 BS 8007 1987. Testing of structure, that is up to 11.5 meter, which 11.5 meter, which should take 14 days, and then we retain for a stabilizing, absorption and autogenous healing period of 7 days for maximum design crack width of 0.1 meter mm. What it says? It says first phase testing. Tank completely protected coating as specified and sealed. Well, it depends. Means BS 8007 doesn't accept that, but something wrong with the specific. Well, we are talking of procedure. And sealant applied shall be cleaned and filled to normal maximum level to meet requirements of clause 8007 1987. Testing of structures, that is up to 11.5 meter, it should take 14 days, and then be retained for a stabilization, absorption and autogenous healing period of 7 days for maximum design crack width of 0.1 mm. Test period starts now for 7 days and drop in level. Recording be made every 24 hours during this 7 days period. Total permissible drop in level allowing evaporation etc. should not be more than 1/500 of average water depth of full tank, which limits to 10 mm or another specified or calculated amount. Having test been successful, backfill shall be carried out. Foregoing explanation provides application of concrete protection coating prior to water tightness testing, but preferably coating should be applied post successful water tightness testing. On site where this project was carried out, application of coating was made prior to testing. Factually, on projects, decision depends on all team members, including engineer and consultants. Second phase testing. Second phase testing. Tank shall be further filled up to 13 meter level, that is another 7 days should be allowed. Stabilization period another for 7 days for absorption and autogenous healing. Test period another 7 days, level drop recording at an interval of 24 hours. Evaporation. Since evaporation loss is required to be included for this test, as it is to be tested in open, exposed to sky, but There is no formula applicable to such testing condition. Loss of evaporation shall be monitored in resemblance only by keeping a water filled tray on surface of water during test by noting original level when filled. Now, during testing and recording, test observations from tray would also be recorded for incorporation into main observations. Though size of basin is much more than that of monitoring tray, yet an idea about evaporation would assist in calculations. Basin filling and testing schedule. First phase water pumping, 14 duration in days, 14 pumping from sea, that is 14 days pumping of sea. Then retained water stabilization to allow absorption and autogenous healing, 7 days. So 14 and 7, 21 days. 14 is for filling and stabilization period 7 days. Then testing at 24 hours intervals and monitoring, that is 7 days more. Loss should not be more than 1/500 of average full water depth of 10 mm or other specified value, but excluding evaporation. Now backfilling after successful testing, 14 days. So 14 plus 7 plus 7 plus 14, this is 42 days. Now second phase, this was first phase, 14 days for filling and then retention for 7 days, testing for 7 days, and backfill after successful testing for the successful testing otherwise. Second phase, water pumping, 7 days, pumping from sea, retention period or retained water stabilization and autogenous healing 7 days, and testing at 24 hours interval 7 days. Water loss monitoring, loss should not be more than 1/500 of average full water depth of 10 mm or other specified value, but excluding evaporation. Now code provides for notwithstanding satisfactory completion of test, whatever evidence of seepage of liquid to outside faces of liquid retaining walls should be assessed against requirements of specification. Whatever necessary remedial measures, remedial treatment of concrete, cracks or joints should, where practicable, be carried out from liquid phase. When a remedial lining is applied to inhibit leakage at a crack, it should have adequate flexibility and have no reaction with stored liquid. Should the structure not satisfy 7 days test, then after completion of remedial work, it should be refilled and, if necessary, left for a further stabilization period followed by a further test of 7 days duration should then be undertaken in accordance with this clause. Equipment in this case are pumps YHP 35, 2 numbers, other general arrangements, hose pipes, attachments. Okay, that is there, that's no meaning. So we have gone through this small procedure, how to do this test. Just for your elaboration, I read it so that you may understand how to calculate this engineering activity. This is very important part of water retaining structures, and I have already given to you importance of this big tank, which is 100 meter by 80 meter and 6 meter and 10 meter depth in 2 locations and slope, and then sketch of this I have given to you. This is sketch, scope. These 2 points are very important. And now we'll go to, I think you got this point of water retaining importance. It's a very, very important point. We can't take it for granted. It's a very important point in structural engineering, and It takes time and we have to cover contract time accordingly. You can't ignore this activity just because you don't like. It's very important. It may not be necessary. This is also such a big tank. Even a small tank, underground tank or ground tank or overhead, whatever it is, all are tested. Must be tested. It was a case of water retaining structure of seawater basin. This could be underground some underground sump tank, or it could be lagoon, or it could be outfall chamber. It can be whatever else. You can say smaller big tank, all according, or maybe swimming pool or whatever. You can't say no. It has to apply. This is a professional activity, and if your tank is not tested accordingly, you are you cannot give tank stability certificate. And if you give, you are not honest to yourself. So simple. Now I'll move to personal qualifications and certifications. Let us say personal qualification and certifications. I start because I'm going to complete this. I'm going to tell that we'll review of all specifications. Personal qualifications and certifications. General auditors, ready mix concrete companies, technical departments, production and operation department, testing laboratories, concrete laboratory department, contractors, contract, concrete construction department, consultants, site supervision department, site supervision design office department. Now, personal qualifications and certifications. Qualifications requirements given in this part are optional unless otherwise mentioned below. Purpose of qualification is to prepare industry to cope with required quality of construction. Requirements shall become compulsory as and when stated by Qatar standards. Qualification shall be approved by Qatar standards or their representatives or wherever work is done. Auditors. Now, Qatar standards auditors and their approved representatives shall be qualified for inspecting concrete ready mix plants and testing laboratories. Ready mix companies technical department position technical manager, QC manager. Qualifications. Concrete specification review and concrete mixture proportioning. That is concrete specification review and concrete mixture proportioning. That is concrete constituent materials, their characteristics and effects on concrete properties. Fresh and hardened concrete properties, durability of concrete, production and delivery of ready mix concrete, handling, placing and curing of concrete, specifying and evaluation of concrete strength, testing of concrete and its constituent, quality control procedures and statistical analysis, hard weather concreting, tumbling concrete problems. So you can say technical manager, quality control manager, or whosoever must have this knowledge, which is a part of qualification here. And I think that's right way. What that person should know? He should know concrete specifications and concrete mixture proportioning, concrete constituent materials, their characteristics and effects on concrete properties, fresh and hardened concrete properties, durability of concrete, production and delivery of ready mix concrete, handling and placing and curing of concrete, specifying evaluation of concrete strength, testing of concrete and its constituent, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. This means this knowledge cannot be had by an ordinary professional. One should be an engineer, qualified and experienced engineer. Only then one can understand. पानी गिर रहा है. One can understand what is necessary and what is not necessary. So this is very important fact. पानी गिर रहा है तो है नहीं, क्या करेगा? Just a minute please, I cannot go there. कोई है नहीं यार, Just a minute, please.
The person you have called is speaking to someone else. You can. The person you have called is speaking to someone else. You can wait. Hello.
अरे पानी गिर रहा है, जरा दिख लेना आके. पानी गिर रहा है नीचे. पानी गिर रही है. पानी गिर रही है. So this is one should know all this, means one should be perfect engineer, only then one can know, otherwise you cannot fix that person as technical manager or professional manager. Then go on to site supervisor. Position is site supervisor. Supervisor shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests. Testing fresh concrete sampling. ASTM C1064 C1064M, temperature of freshly mixed hydraulic cement concrete. किसने बंद किया पता कुछ? अच्छा आवाज़ मैंने दी तो सुना नहीं किसी ने. चलो क्या, ठंडा नहीं पीऊँगा मैं, चाय बना देंगे, मेरा गला खराब जाता है उससे. Supervisor shall be capable of his test. Supervisor shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests. What are those? Let us see what are those. BSCN 123501 testing fresh concrete sampling. ASTMC 1064 61064M, temperature of freshly mixed hydraulic cement concrete. BSCN 12350-2 testing fresh concrete slump test. BSCN 12350-6 testing fresh concrete density. BSCN 12390-2 testing hardened concrete, making and curing specimen for strength test. ASTM C1611M standard test methods for slump, flow of self-consolidating concrete. So this qualification also demands higher qualification. This requirement given here for supervisor, that one should have good experience of concrete, otherwise you should know what concrete is. Position is lab supervisor. Qualification requirement is supervisor shall be capable of satisfactorily reading, understanding and performing below fresh and hardened concrete test. BSCN 12350 testing fresh concrete sampling. ASTM C1064 60164M, temperature of freshly mixed hydraulic cement concrete. BSCN 12350-2 testing fresh concrete slump test. BSCN 123506 testing fresh concrete density. BSCN 12350-6 7 testing fresh concrete air content. Pressure method. BSCN 12390-2 testing hardened concrete, baking and curing specimen for tests of strength tests. And ASTM C1611M standard test method for slump flow of self consolidating concrete. BSCN 12390-3 test hardened concrete, testing hardened concrete, compressive strength of test specimen. BSCN 932-1 aggregates method of sampling. BSCN 932-2 aggregates method of reducing laboratory samples. BSCN 9331 aggregates determination of particle size, distribution and dust content. BSCN 1097-6 aggregate determination of particle density and water absorption. BSCN 1097-3 aggregate determination of loose bulk density and voids. ASTM C566 method of determination of moisture content. Then site technician compulsory if requested by engineer. The requirements are technician shall be capable of satisfactorily performing below fresh concrete tests, that is BSEN 12350-1 testing fresh concrete sampling, ASTM C1064 C1064M temperature of freshly mixed hydraulic cement concrete, testing fresh concrete slump test, BSEN 13506 testing fresh concrete density, BSEN 12390-2 testing hardened concrete, making and curing specimen for strength test, ASTM C1611 C1611M standard test method for slump flow of self-consolidating concrete. Then position is lab technician compulsory if required by engineer. Requirements: technician shall be capable of satisfactorily performing below fresh and hardened concrete tests. Same BSCN 123501 testing fresh concrete sampling, ASTM 1064 temperature of freshly mixed hydraulic cement concrete, BSCN 123502 testing fresh concrete slump test, BSCN 12350-6 testing fresh density, BSCN 12350 testing fresh concrete air content pressure method, BSCN 12390-2 testing hardened concrete making and curing specimens for stand test, and ASTM C1611C 161M standard test method for slump flow of self-consolidating concrete. Then BSCN 12390-3 testing hardened concrete compressive strength of test specimen, BSCN 1932-1 test aggregates method of sampling, BSCN 932-2 aggregates method of reducing laboratory samples, BSCN 9332 1 aggregates determination of particle size distribution and dust content, BSCN 1097-6 aggregates determination of particle density and water absorption, BSCN 1097-3 aggregate determination of loose bulk density and voids, ASTM C56 is method of determination of moisture content, production and operation department, position plant production operation manager and a supervisor, qualification properties of concrete and its constituents, material management, plant design, function and maintenance, batching operations, procedures and dispatching, material management and inventory, safety regulations and procedures. Position is plant operator, qualifications, basic concrete properties and characteristics of its constituents, scales, meters and batching, scale sequence and control system, central mixing and discharging, tolerances, overweight, underweight controls, troubleshooting scales, gates and other plants, components, safety procedures, testing laboratories, concrete laboratory department, laboratory manager, QC manager, qualifications requirement, concrete specifications, review and concrete mixture proportioning, concrete constituent material, their characteristics and effects on concrete properties, fresh and hardened concrete properties, durability of concrete, production and delivery of ready-mix concrete, handling, placing and curing of concrete, evaluation of concrete strength, testing of concrete and its constituents, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. Now supervisor qualifications. Supervisor shall be capable of satisfactorily reading, understanding and performing below fresh and hardened concrete test, BSCN 12350-1 testing fresh concrete sampling, ASTM 1064-1064M temperature of freshly mixed hydraulic cement concrete, BSCN 123502 testing fresh concrete slump test, BSCN 12350-6 testing fresh concrete density, BSCN 12350-7 testing fresh concrete air content pressure method, BSCN 12350-2 testing air hydraulic concrete making and curing specimen for strength test, ASTM C1611-C1611M standard test method for slump flow of self-consolidating concrete, BSCN 12390-3 testing hardened concrete compressive strength of test specimen, BSCN 932-1 aggregates method of sampling, BSEN 932-2 segregates method of reducing laboratory samples. BSEN 933-1 aggregate determination of particle size, distribution and dust contents. BSEN 1097-6 aggregates determination of particles, density and water absorption. BSEN 1097-3 aggregates determination of loose bulk density and voids. ASTM 6 C56 is method of determination of moisture content. Position technician compulsory if requested by engineer. Qualification requirement: technician shall be capable of satisfactorily performing blow, fresh and hardened concrete test. BSEN 12350-1 testing fresh concrete sampling. ASTM C1064 C1064M temperature of freshly mixed hydraulic cement concrete. BSEN 12350-2 testing fresh concrete slump test. BSEN 12350-6 testing fresh concrete density. BSEN 12350-7 testing fresh concrete air content pressure method. BSEN 12390-2 testing hardened concrete making and curing specimen for strength tests. ASTM C1611 C161MS. I'm standard test method for slump flow of self-consolidating concrete. BSEN 12390 is testing hardened concrete compressive strength of test specimen. BSEN 932-1 aggregate method of sampling. BSEN 932-2 aggregate method of reducing laboratory samples. BSEN 9331 aggregate determination of particle size, distribution and dust content. BSEN 1097-6 aggregate determination of particle size, particle density and water absorption. BSEN 1097-3 aggregates determination of loose bulk density and voids. ASTM C56 is method of determination of moisture content. Now contractors, concrete construction department, site engineer, what he should do or should know. Site engineer shall be capable of satisfactorily reading, understanding and performing below fresh concrete test. BSEN 125350-1 testing fresh concrete sampling. ASTM C1064 C1064M temperature of freshly mixed hydraulic cement concrete. BSEN 1350-2 testing fresh concrete slump test. BSEN 12350-6 testing fresh concrete density. BSEN 12350-7 testing fresh concrete air content pressure method. BSEN 12390-2 testing hardened concrete making and curing specimen for strength test. ASTM C1611 C161M standard test method for slump flow of self-consolidating concrete. Position: QC manager, QC engineer, material engineer. Qualification: should know about concrete specification review and concrete mixture proportioning. Concrete constituent materials, their characteristics and effects of concrete properties. Fresh and hardened concrete properties. Durability of concrete. Production and delivery of ready mix concrete. Handling, placing and curing of concrete. Specifying and evaluating of concrete strength. Testing of concrete and its constituents. Quality control procedures and statistical analysis. Hard weather concreting, troubleshooting concrete problems. Consultants, site supervision department, site inspectors, material inspectors. Qualifications: site engineer shall be capable of satisfactorily reading, understanding and performing below fresh concrete tests. BSEN 12350-1 testing fresh concrete sampling. ASTM C1064 C1064M temperature of freshly mixed hydraulic cement concrete. BSEN 12350-2 testing fresh concrete slump test. BSEN 12350-6 testing fresh concrete density. BSEN 12390-2 testing hardened concrete making and curing specimen for strength test. ASTM C1611-C1611M is standard test for method for slump flow of self-consolidating concrete. Site supervision, design office department. Position: material engineer. Qualification must be concrete specification review and concrete mixture proposing. Concrete constituent materials, their characteristics and effects on concrete properties. Fresh and hardened concrete properties. Durability of concrete. Then production and delivery of ready mix concrete. Handling, placing and curing of concrete. Specifying and evaluating concrete strength, testing of concrete and its constituent, quality control procedures and statistical analysis, hot weather concreting, troubleshooting concrete problems. and that's what we say. That's what we say. We can say that this is minimum requirement here, and I think it's too early. We can't say like this to close it. We have to move further, and let's say what we have here. Let's go back and let's go back and see what in this part we have done. This is certification of author or this talk maker, and this was method statement part I given. uh, Now we have some revision here, what actually we did for this concrete. In this we said that this section 5 part 1 general it was in by general, and in this general were given. Then general is introduction and what scope is, where it is, which concrete takes. It takes pipelines, roadworks, runways, structures, water retaining structures, foundations and bases for structures and equipment, and you know various references were talked of, and you know these notations and various notations again, field quality control issues and materials and what actually we are looking for, all that. Then aggregates we talked of in part 2, all kinds of aggregates we talked of in part 2. Same codal provisions, codal numbers, and all details of aggregates. And then we talked of all the details in whatever complete details of that, testing details and other details. And then you can say aggregate was a long one. Now still it's aggregate here. Then cementitious materials we talked in part 3 of this section. Cementitious materials we talked of, and this very important viewpoint from replacement of cement. Very important point here, not to use one cement OPC all way, but replace that for many reasons, so as to make concrete low shrinkage effect, to reduce cracking as much as possible, of course to delay final setting for something, but to control temperatures of concrete and all that. In this part we talked cementitious materials. Then we moved on to that thoroughly with all codal provisions as usual, sources, quality, etc. These cementitious materials, which is replacement like PFA, DJBS microsilica, and all that. Then water, which is important part of concrete. Water requirement, and of course we talked all whatever is expected of that in this. And then we move to admixtures, technology of admixtures, what actually you expect of admixtures. Admixtures means different types of plasticizers or others, waterproof admixtures, all that we studied in this part. And then we crossed over to this to reach property requirements. Property for everything, whatever you do, property requirement. And what we did in that, this. All provisions. Oh, and classes XO, class X1, class X1, X2, X3, X4, etc. And you can say PC, FA, GGBS, and then all these properties including silica fumes, exposure classes, and others. And we moved on to onto this long one. Continuing. Property is very long. And this is concrete plants. Means batching plant. Uh, 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 concrete plant is a mechanical system with complete concrete technology. Then it is concrete plants inspection checklist. Mhm. Transportation and placing of concrete. Oh. Form work. Now comes preparatory works. Form work. Form work is preparatory work, very important work. Oh. 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 Curing. 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 reinforcement, joints, joints, important one, joints. Inspections and testing. Inspection and testing, very important chapter. Protective treatment for concrete layers, water treatment, waterproofing. Hard weather concreting, most important. Oh, miscellaneous, miscellaneous. Oh, 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 oh.